Hello everyone. Now we are in chapter 2. We are going to deal with logarithm. I'll just go straight to the important part. It says, in general, if n equal to e raised to power x, then log a n is equal to x. Now it says the logarithm to a given base of a number is the power to which the base must be raised to make the number. Let's explain this on our notebook. Now, what it's trying to say is that this is the explanation. Say the logarithm to a given base. Now, what is the base of logarithm? This one here. This is log. And first, this is an indices. So they are trying to use this indices to explain this logarithm. So they say the logarithm to a given base. Now, this is log, this is base, and this is the number of a number is the power to which the base must be raised. So if you are, when you're in your junior secondary, you do more of logarithm base 10. Now we're trying to do logarithm in other bases. So for that reason, we have to explain logarithm implicitly and very well, so you understand what you are doing. So this is the base. They say log n in base a is equal to what? They are trying to say that this a raised to power, whatever you are getting as the answer, is what will give you n. And this is the indices explanation. It means n is equal to e raised to power x. So let me just try to explain it here. It's trying to say that when you have something like this, let me say you have log b c is equal to what? Let's assume here is a. So you can rewrite this by saying b raised to power a will give you c. So you can say b raised to power a is equal to c. So that was what logarithm is all about, and that's what the explanation, that's what explained this sentence here. Now we have examples to deal with. So this example A, we have this. You have log 32 is equal to what? Now you're looking for what this answer will give you. From what we have done here and from this explanation, you can say 2 raised to power what will give you 32. So let's change this to indices form. It will be 2 raised to power x will give you 32. This is what we are going to solve to get x. What we are going to do is reduce this to the base of 2. Indices also have its own base. So reduce this to the smallest form. You understand? What we are going to do is 2 raised to power x is equal to 32 is the same thing as 2 times 2 times 2 times 2. 1, 2, 3, 4 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. You now have 2 raised to power 5. Since these two are equal, it means that this 2 is also equal. This x is also equal to this, because 2 raised to power x is also the same thing as 2 raised to power 5. So since they are now in the same base, x is now 5. So the answer to this A is 5. Let's go to number B. Log 927. Now we are trying to look for what the power 9 will be raised to give you 27. So I will now say equal to x. I will now say log 9 raised to power x will give us 27. So 9 raised to power x will give us 27. So what we are going to do is to reduce this one to the smallest form and also reduce this one to the smallest form too. So the smallest form of 9 will be 3 raised to power 2. 3 times, so it will be, let me show full working. It will be something like 3 times 3 all raised to power x. And here we also have 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. So 3 times 3 is 3 raised to power 2. 3 raised to power 2 all raised to power x is the same thing as 3 raised to power 3. The next thing is 3 raised to power 2x is the same thing as 3 raised to power 3. Now, when you open bracket, if you have indices, this is, you see this one under the laws of indices. When you have something like this, 3 raised to power 2, that's 3 square, and you have in a bracket, the bracket is still raised to power another indices. When you open the bracket, this and this will multiply each other. That's what we did here. So from here now, they have the same base. Since they have the same base, you already know that 2x is now raised to power 3. Let's go to the next page. So let me write it out again. Equal to 3. Since they have the same base, you now know that 2x is equal to 3. Now I've taken the indices. Once they have the same base, the indices are equal. Take note of that. So x is now divide both sides by 2, 3 over 2, which is written as 1.5. So the answer of the second one is 1.5. The answer of this, let me write the question back here since we can't see it again. The answer to this question, this is 9, not A, is 1.5. So the third question says log 5 0.04. This is the third question. So I can equate it to x. Now we are looking for this x. We're trying to look for what this will give us. So I can equate it to x. So I can say 5 raised power x will give me 0.04. So 5 raised power x 0.04. Now this is already dicey. There is no how we can solve this like this. So the best thing we can do is to try to change this thing in a form where it can be easy to solve alongside with 5, since 5 is the base here in the indices. So this can also, this 0.04 is the same thing as, if you change, you know how to convert indices to fraction, it will be 1 to 4 over 100. So 4 can divide 100. 4 divide here 1, 4 divide here 25. So 5 raised power x is the same thing as 1 over 25. I think this is a better way to solve it. Now, because we are dealing with logarithm, and this is logarithm and indices combined, you might need to know the laws of indices to understand what we are doing. But I will say it here, and then you can also check it on the video we have on indices to understand the laws of indices better. So going forward, this is the same thing as in indices. Whenever you have 1 over something, you can also express that as, this 1 over 25 can also be expressed as 25 raised to power minus 1. This is the law of indices, the inverse rule. Because it's 1 over 25, you can also express that 25 now on top is no longer a fraction, but the indices will be -1. So you now have 5x is raised to power is 25 raised to power minus 1. So you reduce this thing further. You have that 5x is equal to 5 times 5, all raised to power minus 1. This is equal to 5 raised to power 2, all raised to power minus 1. You now use the indices rule. These two will multiply this minus 1. So 5 raised to power x will give you 5 raised to power minus 2, because this is multiplying this. So since now both of them are now in the same base, you can now say x is equal to minus 2. This is the answer to this example. Let's solve exercise. So in this exercise 2a, we are going to solve for the ones I think that will be the hardest. I will choose this number 20. I also choose this number 1 is simple. Number 4, I'll choose it. Number 4 is simple too. I'll choose it. Then I also choose number 16, 20, 4, and 16. So let's get down to it. So these are the numbers we're going to solve. Let's solve for number 4. Number 4 is very simple. We have log 381 is equal to what? X. Now we are looking for x. 3 raised to power x will give you to 81. So you have 3 raised to power x is 81. Now let's solve for x. Reduce this 81 to the lowest form. 81 is the same thing as 3 times 3 times 3 times 3. That's 3 raised to power 4. So you now say 3 raised to power x is equal to 3 raised to power 4. Since both of them are in the same base, x is now equal to 4. That's for number 4. Let's solve for number 16. Number 16, log 100 0.001 is equal to what? X. And don't adding is equal to x, but we're looking for x. Now say 100 raised to power x is equal to 0.001. Now let's reduce both sides to the lowest. The lowest we can have for 100 is the lowest base. Also, let me take note of this. The base you're looking for is the base that will give you one base. You know, you can reduce this thing to something like 4 times 25. You now have something like 2 raised to power 2 times 5 raised to power 2. That is not accepted. What we are looking for is a single base that will still give us the answer, the indices we are solving for. So that's why I'm choosing those bases that you see me choose here. So this is 10 times 10, so it will be 10 raised to power 2 or raised to power x equal to, these are indices, so you change it to fraction. Remember what we did in the last example. It will be, how to change to fraction, 1, 2, 3. This decimal here will be 1, then the other things there will be 0, so it will be 1 over 1, 2, 3. And remember what I said in the other law of indices, that when you have, okay, this is first 1 over 10 raised to power 3, because 10 times 10 times 10 will give you 1000, so 10 raised to power 3. And negative indices, this one will now be this multiply this, 10 raised to power 2x is now equal to, this is 10 raised to power 3. When you bring it up, it will be 10 raised to power minus 3, using the law of negative indices. When you bring the denominator up to the numerator, the indices power will now take a negative answer, a negative form, I mean to say. So since these two bases are the same, 2x now is equal to minus 3. So your x is now minus 3 over 2, which is minus 1.5. That's for number 16. Let's solve for number 18. Number 18 says, this is number 18, log 8 0.02625 is equal to x. So 8 raised to power x is this. So 8 raised to power x is 0.0625. Now we start reducing to the lowest form. This is the single base that will reduce. This is 2 raised to power 3. 2 raised to power 3, because 2 times 2 times 2. 2 times 2, 4. Times 2 again is what? 8. So 2 raised to power 3 is, now this is indices, we change it to fraction to be 1625 all over. This decimal point will take 1, then 1, 2, 3, 4. 1, 2, 3, 4. That's how you convert decimal to fraction. So if you divide, let's not make this thing too long, because I can divide it 5 here, 5 here, 5 again, until I get the lowest form. But when you divide 625 here, you will get 1. If you divide 625 here, you get 16. You can check it with your calculator, or you can still go the long division method, where you divide and divide, you keep dividing till you reach to the lowest form. So now 2 raised to power 3 or x is equal to 1 over 16. As you can see in this class, I'm trying not to repeat myself often as I did in the class with sword. So let's go on. Now when you open up the bracket for here, negative indices, here is, this is equal to 1 over 2 raised to power 4. Remember, we are using a single base in this case, unlike in sword where you can have many bases. So 2 times 2 is 4. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So that's why I have 2 raised to power 4. Here, when you open up the bracket, it becomes 3x equal to 1 over 2 raised to power 4. Now when you bring this number up using the negative indices rule, it becomes 3x equal to 2 raised to power negative 4. If you remove it from the negative, from the denominator and take it in the numerator, the power will not take a negative form. So since both of them are now the same base, 3x is equal to minus 4. X will be equal to, divide both sides by 3, minus 4 over 3. I'll leave it in this form. Since if you divide it to decimal, you keep getting 1.3333. So this fraction form is okay. The final one is number 20. Number 20 is log 0.225. This is the question. I will say it's equal to x. So I'll now do log, 0.2 raised to power x is equal to 25. Now this is in decimal, so I'll change it to fraction. It will be 2/10. The decimal point will be 1, while the other, or anything behind the decimal will become 0. So this is a x equal to, this is 5 square. So 2 raised to power 10 is same thing as 1/5. 1/5 x is same thing as 5x, 5 square. So here we'll bring it up. 5 raised to power negative 1x equal to 5 square. So these indices power multiply each other. You now have 5 raised to power minus x equal to 5 square. Since they both have the same base now, minus x is now equal to 2. So x is equal to minus 2. So this is it for this class, where we try to solve logarithm and indices. Thank you, and see you in the next class.